Hi, I'm Avery Schwartz here. I'm here to tell you a little bit about chemical calculations and moles, etc., and stuff like that. Alright, and one of the first things that you need to know about chemical calculations is how to get to each level. So, I'll make a little flow chart here. In the middle here, you have what are called moles, which are pretty much the central part. In order to get to anything, you need moles. And off of that, you have grams, and then this way you have volume or liters, and then up here you have like atoms and slash particles and stuff. Alright, and pretty much to get to each thing, if you're going to go from moles to atoms, you would essentially you multiply by this number, which is called Avogadro's number, and he was just an Italian physicist, but yeah, you can multiply. And to go 2 moles from the amount of atoms, you would divide by this number right here. And if you're going down to grams, you would multiply by the molar mass, which I will tell you how to get to that in a little bit. And if you're going to go from grams to moles, you would divide by that same molar mass that you found. And then over here in volume, you're going to go from moles to the volume, you would multiply by 22.4. And if you're going to go from volume to the moles, you would just divide by this same number right here. Alright, now I'm going to show you an example problem of how you would use the chart in this situation. So let's say you were given 4.5 moles of helium. Alright, and you want to see how many particles that amount of helium would get. So what do? You take 4.5 moles and you would multiply that by 6.02 times 10 to the power of 23. And then with this answer right here is about 2.7 times 10 to the power of 24 particles of helium, and then this would be your answer right here. So it's not extremely complicated, but if you could mess up here by like not putting your parentheses around, that would mess up the whole entire problem. Alright, the next thing I'm going to talk about is molar mass. And molar mass is another not very complicated topic, but it is necessary. So pretty much the molar mass is, the atomic mass of an element is pretty much like hydrogen's is 1.0079. That's its molar mass, right? And it is the atomic mass, molar mass is the exact same. But let's say you get one like copper chloride. Alright, what do? You take the mass of copper, which is 63.546, and you take the mass of chloride, which is 35.453, but because there's 2, you multiply this number by 2, and then whatever this plus this times 2 equals would be your answer. And I think that it is approximately 134 grams. Alright, now I'm going to use the information we learned about the molar mass to tell you how to get from the mass of an element to the amount of moles that it has. So remember on our flow chart, if you have the mass, let's say you have approximately 2 grams of hydrogen. Alright, now what you do with this number is you take the 2, and remember if you're going from mass to moles, you want to divide by the molar mass. So then you take this number and divide it by the molar mass of hydrogen, which is 1.0079 actually about. So divide on 1 grams. And then this number right here would be the amount of moles are in 2 grams of hydrogen. And that number is about, I think, 1.98 moles of hydrogen are in 2 grams of hydrogen. Alright, now I'm going to take what we learned from the basic problems and I'm going to make it a little harder problem here. Alright, in this problem we're going to go from molecules all the way to grams. Alright, so first thing here, you would take this number right here and simply divide it by, since you're going down to moles, you would divide it by 6.02 times 10 to the power 23. And then there you would get about 0.02176 moles of glucose. Alright, then you take this, alright, here, and remember you have to multiply by the molar mass to get the grams. So you'd find, first you have to find the molar mass of glucose right here, which you go first go by each individual one. So this is 72.066. This is 12.0948. And this is 95.994. Okay, and then you'd add up the total of this right here, and you get about 180.1548 grams. And then you simply multiply this number right here by this number right here, and you get 3.92 grams. And this is your answer right here. Oh. Alright, now I'm going to try to do what is a very complicated problem here, and it's going to combine everything that we have learned so far. Alright, so this is essentially, this is an entire chemical equation right here. And the question is for this is, we're trying to find the mass of HCl, which is right here. We're trying to find how much of that is needed to prepare 1 mole of Cl2 gas. Alright. So the first step in when you're ever dealing with a chemical equation is you have to balance it. So this is pretty simple. You just remember, you just go through. So like, and first you start with the K and see, so right there it's the same, and then you go over to magnesium right here and you see right there that match, and then you go to chlorine, because remember we do oxygen, hydrogen last, and chlorine is a little bit it's not even. So you try to balance it, and if you end up doing it and include oxygen, hydrogen in it, you have to go get 2 here, 16 hydrogen chloride here, 2 magnesium chloride, 5 just regular chlorine gas over here, 8 H2O, and 2 potassium chloride right here. Alright, so after it's all balanced, what I like to do when you're trying to go from moles, defined from mass to moles and stuff like that, you can look for the ratio with HCl right here. Alright, so you're trying to find out how much HCl is in chlorine gas right here. Alright, so what do? You see it's 16 to 5. So this is the ratio. This is very key. This right here is the key to the whole thing. Right. So after you do this, you simply find the molar mass. So of H, it is 1.0079, and Cl, it is 35.453. You take that, add it up, get the molar mass, which is 36.453. 0.4609. And then you take that and the 16 moles. And, alright, cut it. Alright, and then you take the answer you got right here, and you're going to multiply it by 16. And after you do that, you get about 583 point, look here, 3744 grams. Alright, and then you take this number and you go back up to the ratio right here. You take this 5, and you simply just divide this by 5. And then you get 116.67 grams. And this is the amount of mass needed in HCl to prepare the chlorine gas. Alright, the next topic I'm going to be talking about is percent composition. And this is a pretty basic topic, it's just a little tedious. So first I'm just going to start off with an example here. What you do here, you take like one compound, like let's take acetate for example, which is C2H3O2, okay? Now you're going to take this and you're going to split it up individually. So you go C2 here, H3 here, O2 down here. Alright, and then what you do, you're just going to find each individual molar mass for each one. So the one for C2 is this 24.022. The one for H3 is 3.0237. And then for O2 is just 31.998. Okay, and the way you do, again, find the total molar mass, you just add up all of these right here. And you get 59.0437. Okay, now you have to find the percentage. So what you do is you take each individual one and you're just going to divide it by the total molar mass. So you take 24.022 divided by 59.0437 and you'll get 40.6%. Okay, and then you're just going to take this, the 3.0237 divided by the total mass, and you're going to get 5.1%. And then you're just going to take O2, 31.998, and divide it by this again, and you're going to get 54.2%. And this is your percent composition for acetate. Alright, now we're going to talk about a new topic, the limiting and excess reactants. Alright, so the limiting reactant is essentially the reactant that prevents the reaction from becoming as big as it can get, you know. It limits the amount that the reaction could actually produce. Alright, and the excess, obviously, is the extra the extra products that were created from the reaction. So alright, and I'll put this into simpler terms for you. Pretty much like, let's say you have like 8 car bodies. Alright, and let's say you get about like 50 tires. Alright, so you need 4 tires for each car, and 8 times 4, that's 32. Alright, so you can only make 32 cars with the amount of tires and car bodies that you're given. And then with the leftover tires, that would be the excess, and the 8 car bodies would be the limit. Alright, thank you all for watching this video. I hope you learned a lot about chemical calculations and the mole concept and everything in there. Why don't you everybody go ahead and follow me on Instagram and add me on Snapchat at AveBoss24 on Instagram and Avery.Schwartz on Snapchat. Thank you all again, and Peace out.